There are only 100 or more elements in the world, but these elements are combined chemically in various forms to form more than 21 millions of compounds. Almost everything you see is a type of compound. To understand how a compound is formed, let's look at today's lesson.
The content standard for this lesson is 6.3 Compound. At the end of this lesson, you are able to communicate about compounds in daily life, demonstrate the formation of compounds between metals and non-metals, conclude that mass is conserved during a chemical change. What will happen to a nail if it is left out in the open for a few days? It will rust. The nail rusts due to the chemical reaction of iron with oxygen and water. In this reaction, iron will combine chemically with oxygen and water to form a new substance. This new substance is called a compound. What is a compound? Let's find out. A compound consists of two or more elements that are combined chemically in a chemical reaction. This newly formed product has its own characteristics. For example, rust is a compound formed by chemical reaction between iron and oxygen. Unlike mixtures that can mix in any proportion, in the formation of a compound, the proportion of these elements is fixed. For example, carbon dioxide is a compound formed by chemical reaction between carbon and oxygen. One carbon atom combine with two oxygen atoms to form a carbon dioxide molecule. Water is a compound formed by chemical reaction between hydrogen and oxygen. Notice that there are more than one type of atoms in the molecule of a compound. Another example of compound is sodium chloride or common salt. Sodium chloride is a compound formed by chemical reaction between sodium and chlorine. Ammonia is a compound formed by chemical reaction between nitrogen and hydrogen. Metals easily react with non-metals such as oxygen, water or sulfur to form compounds, which are new substances with different properties from their original elements. Some metals react with oxygen to form metal oxides. For example, magnesium reacts with oxygen to form magnesium oxide. Aluminium reacts with oxygen to form aluminium oxide. Some metals react with water to form alkaline compounds and release hydrogen gas. For example, lithium reacts with water to form lithium hydroxide and hydrogen gas. Sodium reacts with water to form sodium hydroxide and hydrogen gas. Some metals react with sulfur to form metal sulfides. For example, iron reacts with sulfur to form iron sulfide. Iron sulfide is a compound. To form a compound, a chemical reaction will have to take place. Heat is absorbed or released during a chemical reaction. When elements are combined during a chemical reaction, a new substance is formed. This new substance is a compound. Do the elements in the compound form retain their original properties? Let's find out. Iron and sulfur are elements. Every element has its own physical properties. Sulfur is yellow in color and cannot be attracted by a magnet. Iron powder, on the other hand, is grey in color and is attracted by a magnet. When these two elements are mixed and heated together, they will react and form a compound called iron sulfide. Iron sulfide has physical properties that are different than that of the original elements, iron and sulfur. Iron sulfide is a black color compound and it is not attracted by a magnet. Therefore, when elements are combined to form a compound, the compound form will have different physical properties than the original elements. Atoms are neither created or destroyed, but can be split up and rearranged to form a new product during a chemical reaction. The number of atoms remains unchanged after a chemical reaction. Hence, the mass is never lost or gained in a chemical reaction. In other words, the total mass of products at the end of the reaction is equal to the total mass of reactants in the beginning. This is called the conservation of mass. For example, carbon reacts with oxygen to form carbon dioxide. The total number of atoms in the beginning of a chemical reaction is the same as the total number of atoms at the end of a chemical reaction. Therefore, the total mass of reactants in the beginning of a chemical reaction is the same as the total mass of the products at the end of the chemical reaction. Another example is the formation of water. Hydrogen reacts with oxygen to form water. The number of hydrogen and oxygen atoms remain unchanged after the chemical reaction. This means that these atoms are not destroyed but rearranged to form molecules of water. Thus, it can be deduced that the mass is conserved during a chemical change. Next, let's answer a few questions. A compound is formed when two or more elements are. The answer is chemically combined. The physical properties of a compound are different from the physical properties of its elements. Is the statement true or false? The answer is true. Which of the following is a compound? The answer is salt. Which of the processes shown produce a compound? The answer is mixing vinegar and baking soda and lighting fireworks. When fireworks burn, new compounds are produced. When vinegar is poured over baking powder, carbon dioxide gas is produced. Carbon dioxide is a compound.
To end this lesson, let's make a summary on what you have learned about compound. When two or more elements combine together in a chemical reaction, a new substance is formed. This new substance is a compound. The compound form has properties different from its original elements. Usually, during the formation of compounds, there is an energy change. A compound form has a fixed proportion. The ratio of each element in a particular compound is always the same. The mass is conserved during a chemical change. That's all for today's lesson. Thank you.